Hello YouTube, and thank you for watching. Today I want to talk about composite index and the importance of column order. When creating an index, the most selective column should be first. You get a call from a user complaining that their query is running slow, taking about 40 seconds or so. You search the top SQL and identify the query in question, and you get the SQL ID and the child number. Once you obtain that information, you can plug it in here to fetch the execution plan in memory. The execution plan shows that there's two tables. There's a users table and there's a post table. And the post table is fetching records using the table access full, which is reading the entire table from left to right, top to bottom. And it's a strong indicator that you need an index here. The query cost is about 1063K. Let's go about creating an index. And the way to identify the columns to be included in the index is to dissect the query by table. So in our case, we need an index on the post table. What we'll do is keep all references to the post table and delete all references to the users table. Let's do that. And since this is a duplicate, we can delete that. And we have owner user ID, we have last activity date. So these can be deleted. Okay, so let's list the columns. And the way to do that there is by a priority. So the first column to list is in the join. So in our case, it would be the owner user ID. Next is a filter, and we have two filters. We have the post type ID filter and we have the last activity date filter. So for now, we'll just go with that list. Okay? So now what we're going to do is we're going to create an index on the post table using these three columns. So owner user ID, post type ID, and the last activity date. By the way, this is a covering index because it contains all the columns that are in the query. Now that the index is created, let's go ahead and rerun the query. The previous query runtime was about 40 seconds. This time the query is taking about 5 seconds, which is about 8 times faster. Let's confirm that it is using the index that was just created by looking at the execution plan. So we're going to run this with a SQL ID and a child number of 0, which will fetch the execution plan of the last query that was executed. Here you can see the SQL ID and the child number, and the execution plan shows that it is using the index that was just created. The query cost has also gone down quite a bit as well. Let's go ahead and save this information for comparison. Let's go back to the query and talk about the column order now when you're creating an index, where the most selective column should be first. In order to do that, you need to look at the column selectivity. And what we're going to do is use this query looking for posts in the pstream schema. And what this view shows is the table and the columns, the number of rows, and the number of distinct, which indicates selectivity. For example, when you have a primary key, the number of distinct will match the number of rows. And the higher the number, the higher the selectivity. So we have 3 columns. Let's go ahead and look at them. When looking at a query, this is a join, and these are called filters. And the way you order the index in the column is first the join and then the filter. Now the question is, when you're creating an index, which of these 2 filter columns should be first? Let's go take a look at their selectivity. The first column is the post type ID, which has 8 distinct values out of 17 million. Not very selective. The next one is the last activity date. So here you can see that out of 17 million, you have 13.5 distinct values. This is very highly selective and should be first in the column order. So when creating an index, the column order should be first join, then the filters. So we have the owner user ID, and then the filter order should be last activity date followed by the post type ID. Let's go and use this information. So in the original query index that we created, the column order was join and the filters. But here is, you can see, according to the selectivity rule, the last activity date should be first, followed by the post type ID. Okay, so what we're going to do is create another index, and this time using the selectivity rule. Let's go take a look at the indexes that are on the post table. So here are all the indexes on the post table, and you can see we have two indexes with just a difference in the column order. Now, the optimizer will be using the most selective column index over the other. So this index was created first, which the optimizer used previously. Now you'll see that the query will actually prefer using this index. Same query, execute. About the same amount of time, 5 seconds. Let's take a look at the execution plan. So it is using the index. Now which index is it using? It's using OID, last day date, PTID. So it is using the second index. Let's go compare the cost of the query. So again, you can see that the index that is being used is different between the two execution plans, and Oracle actually prefers using this index over the other index. In this case, the query performance didn't change that much. Here, the CPU cost has remained about the same. Execution time remained about the same. There's a little bit of savings in buffers, but it is a significant amount. But it is important to recognize that column order when creating an index matters. Hope you found this information useful. If you enjoy the content, please hit the like button and subscribe. Thank you.